right? So I'd encourage you maybe to practice this one for extra practice on using our difference of cubes. Make sure that you can get those two answers. Okay, let's actually go into today. So today we're going to look at analyzing graphs of polynomials and taking key information from the graph. Okay, so take out your worksheet. Let's look at number 1 on your worksheet. I'm actually going to work through number 1 and number 2 with you. Okay, first thing, I want you to go to Desmos.com. We're going to do all our graphing today in Desmos. Okay, so this is number 1 on your worksheet. So go to Desmos.com. Everybody should be going to this site because we got to run everybody on this right now because we're going to be working with it as our graphing platform. Okay, and let's enter number 1 from our worksheet right here in Desmos. So it's 2x cubed plus 5x squared minus 4x minus 12. Take a second, make sure everybody can graph that one in Desmos. And this is the first step to even being able to do the worksheet today. I want to make sure everybody can graph here in Desmos. Okay, is everybody able to produce this graph on their screen from Desmos? Okay, I'm just gonna minimize my bar on the left. It doesn't matter, you can leave it open or not. Okay, so let's look at answering the questions now. So part A, it says to sketch. And so I'm gonna ask you just to sketch this graph. I mean, Desmos has already drawn it for you, but I want you to make a quick sketch. But I want you to be specific on where it's crossing the x-axis at. It's crossing here at 1.5 and -2. So when you do your quick sketch on your paper, make sure you identify your zeros at a positive 1.5 and at -2. And then letter B says, what are the end behaviors? Okay, so on ours, I want us to identify end behavior. We're going down and up. So end behavior reading left to right, it's down, up. Real zeros and imaginary zeros. This 3, our highest degree on our polynomial, tells us there's going to be 3 solutions. But this 3 solutions could be a mix of real and imaginary, or it could be all real, or it could be all imaginary. So I know there has to be 3 solutions. Solutions meaning how many zeros. So how many zeros are on my graph here? 2, okay? So I have here at a -2, and I also have at 1.5. Let's go back to our idea of multiplicities, though. Okay, so at 1.5, it's going straight through my graph. And so if 1.5 was a solution, if I thought of this in factored form, it would be x minus 1.5 raised to the first power. Because it's a multiplicity of 1, it's going straight through. If my other one is at -2, that means it needs to be an x plus 2. But I can see here at -2, there's a bounce going on. So what's the multiplicity there at -2? It's going to be an exponent of 2. And remember, multiplicities are repeated zeros. So really, my zeros are -2, -2, and 1.5. Because -2 is a zero twice. So in this one, when it says how many imaginary zeros, that's none. There's not any imaginary. That idea of multiplicities is making sure we cover all of our zeros. So we're paying attention to what's happening at the graph at those specific zeros on the x-axis. All right, so for real zeros, -2, -2, and 1.5. The next one that asks about absolute max or min. And it's saying give a word or a value. So absolute is the absolutely highest value that we have or the absolutely lowest value that we have. This is going to positive infinity and negative infinity on my end behavior. Infinity is not an absolute. We don't even recognize that as an absolute value. I mean, it's going to infinity. It's never going to reach it. So this one has no absolute max or min. It's going to infinity and then it's going to negative infinity. Now, relative max or min, we can look at within kind of our end behavior. So on this one, I would look at this value here at -2, this coordinate -2 comma 0. I would say that's a relative max, because if I looked around there, everything's going lower after I go past that max. So you can think of it like a peak in the graph. And then down here, just right on my y-axis, I have a relative min going on. It's not absolute. It's not the absolutely smallest value that I'm going to have, but everything around it is getting bigger. So this would be a relative min. Okay, so for my max, I'm going to say -2 comma 0. And then how do I figure out what that point actually is? So if I go back to Desmos, I can see it's kind of here in the middle of my square. How can I figure out exactly what that point is, Ben? Okay, so these graphs are interactive. If you click, it will show you exactly what it is. So this one's 0.33 comma -12.704. So what I want you to fill in here is a 0.33 comma -12.70 as our min. And again, that's a relative min. That's not an absolute. That's a relative. So relative will be any peaks or valleys in our graph that we have going on. All right, and it's not absolute because it's going up to positive infinity and it's going down to negative infinity. Last thing they ask us about is domain and range. What does domain represent again? Domain of a function. You remember that, Ben? So domain represents the x, range represents the y. Are there any restrictions on my domain? Are there any x values that I won't happen? Like, can I go out to a -100? Yep. Can I go out to a -1,000,000? Yep. And I could do the same thing on the right. I could go to a +100. I could go to a +1,000,000. I could go all the way out to positive infinity. So this would be all real numbers. My domain for this function, I could choose any x value I want, and I will get a number. Okay, going back to my original function that I have there, if I chose x to be anything, I would get an output y. Now my range, is there any restrictions to the range for this one? There's not, because it's going from a positive infinity to a negative infinity. It will do any number in between there will happen. So this one, my range is actually going to be all real numbers as well. So for this very first question, we graph it, we analyze the graph, identify end behavior, identify zeros, look at absolute max and min, look at relative max and min, and then talk about domain and range. Let's look at problem number 2 as well. Let's do this one together. So let's go back into Desmos. When you are plotting a fraction, start with an open parentheses and then put your fraction in. So it says a negative 1/4. So I'm going to go negative. I'm going to open my parentheses and say 1 divided by 4. I'm going to close my parentheses, and then I will do x raised to the 4th power. And then negative 2x cubed minus open parentheses 13 divided by 4 x raised to the 2nd minus 8x minus 9. Let's take a minute, make sure we can all get that graphed in Desmos. And if you see here on my screen, we see basically a vertical blue line. We see kind of a angled blue line. If we zoom out with this toolbar on the right, we can start to see the shape of it a little better. It's real skinny. If we click on the wrench on our toolbar on the right, we can actually change it. So I'm going to restrict my X values. I'm going to say right now it's going, on my graph, it's going from like a negative 100 to a positive 100. I'm going to change this to just say like negative 20 to a positive 20. And I can just see it a little bit better. Just kind of widens it out a little bit more. Okay, so this would be our quick sketch we could put on our worksheets. I want you to be specific on this vertex point. So if you click in Desmos here, it'll tell you where your vertex point is. At your zeros, I want you to be specific. And then also here where it's crossing the y-axis. Okay, it's a sketch, but I want you to identify those points specifically as you're graphing your sketch. Part B asks about end behavior. The end behavior on this one is down and down. And that makes sense because it's a degree 4 polynomial with a negative coefficient. So that tells me it has to have an end behavior of down and down. So I could actually answer that without even graphing it yet. The real zeros. So again, if I look at my graph, I have a negative 6.646 and I have a negative 1.354. Those both have a multiplicity of 1. Those are just going straight through. At negative 1.3, I mean, it starts to look like it's going to snake through, but it's not. That's not an example of a snaking through one. That is going straight through. So each of those have a multiplicity of 1. And I know that it was a degree 4 polynomial, it had to have 4 solutions. So my real zeros would be that negative 6.6, negative 1.35, and then imaginary zeros, I'm just going to say how many there are. There's 2 imaginary zeros. I don't need to identify what they are. I'm just looking. You can't graph imaginary zeros, so they're not going to show up on our graph. So all you have to write there is just how many there are. So So there's 2. Letter D, absolute max or min. Emma. Correct. Yep, just those x coordinates is all you need even. You don't need because the y coordinate will be 0. D, the absolute max or min. So this one, end behavior, it's going down and down to negative infinity. This top peak here is an absolute max. There are no values that are higher than this. And when I'm talking high, I'm talking up and down. So all I'm looking at is I'm looking at the y value on this one. So up and down, my absolute max is 43.5. Okay, there's not going to be a number higher than 43.5. And that's what this line shows us. It goes up to that, and then it starts to go back down. So absolute max, 43.5. There is no absolute min because it's going down to negative infinity on both end behaviors. Relative or local max or min. And all we have is an absolute max. There's no local or relative ones on this one at all because there's no other peaks or valleys where my graph will change. It basically goes down. Once I'm at 43.5, it goes down no matter which direction I go. Domain, getting back to the original function which I've graphed, I could put any x value I want in there. I could put pi in there. I could put 1,000,000 in there. I could put negative 72 in there. It'll work. I will get some output. So all real numbers will be the domain. The range, though, is restricted. So my range is output. So on this one, my highest y value that I'm going to get is 43.5. Any y value is going to be below that. So I would write this as an inequality that my y values will be less than or equal to this 43.506. Okay, I won't have any numbers bigger than that. I will only have numbers smaller. So this one is not all real numbers because it's capped. I'll never get 50 as an output. Okay, this one would be an inequality. Y value is less than or equal to 43.506 would be my range that I can work with. Okay, so finish up 3, 4, 5, and 6. Now I'll give you a hint on number 6. It's a function in terms of t. You need to graph it in Desmos and change those to x's. You can't graph in Desmos using t's. You have to only use x and y's. So on number 6, make sure you just change that to x as your variable, and then it will graph. Okay, so finish this up. Have it ready to go for Monday. We'll talk about it Monday, and we'll start the next section.